Well, hello, my dear ESS students. Today I'm sick, so we are going to be, or I'm gonna record this video, and you're gonna look at it, and that's gonna be our lesson for today, covering chapter 2, 7.3, which we've already kind of started, but let's finish that bad boy. So it's all about how we can fix climate change or reduce the impact of climate change through adaptation mitigation. So this is about the solutions. We talked about the problems. Let's get down and dirty and fix this thing. So there are two ways we do this, is by mitigating the effect and adapting to the change. So mitigation refers to any way we reduce climate change. So the root cause, the levels of greenhouse gases in our atmosphere needs to be limited. And there's basically two ways. We can reduce the emissions so that we don't add more, or enhance removal of greenhouse gases from the atmosphere, because it's the level in the atmosphere that we need to impact. And there are many ways we can do this, by changing energy efficiency of, for example, light bulbs, so to LEDs, and the insulation of our houses, things like that, which energy production systems we use, how much energy we do use through lifestyle choices, and how we manage the land to promote carbon sinks and remove carbon sources through, for example, deforestation. And then we can remove greenhouse gases from the atmosphere either by increased photosynthesis, so enhancing the already natural way of removing carbon from the atmosphere, and various high-tech solutions. But we'll get there. And adaptation is actions to manage the damage, basically. To if we assume a given level of climate change, how will we then cope with that one, and how can we adapt our society so the damage from that level of climate change is not too crazy? So we need to manage sea level rise, we need to secure food productivity, secure water availability, combat new diseases, etc., etc. We're going to get more into it later. So we're going to start at the mitigation end of this little circus. And as we may remember, about 75% of all our greenhouse gas emissions arise from energy use. The rest is through agriculture. So energy use for various things, such as transport, electricity, and heat are the big three. And here we see that energy use varies quite dramatically all over the globe. And you might notice that the more economically developed countries use way more energy. We shouldn't necessarily mix energy and electricity completely, because of course electricity is just part of the energy, how energy is used in society. And so there are of course many different ways to get energy, and those have different impacts on on greenhouse gas emissions and the climate change. So we had this one we've looked at before for chapter 7.1. So we have different energy sources as these little blobs, and we have how many deaths they cause from accidents and from pollution, and we have the greenhouse gas emissions per kilowatt hour of, so that's a measure of energy, kilowatt hour. And we see that on the x-axis then the amount of greenhouse gas emissions per energy unit. So we see that coal is worst in all kinds of ways. It contributes to the most deaths, and it's the most greenhouse gas intensive. So basically, a simple way basically is to oil is slightly behind, but not too much. But basically, if we just shift the world away from coal and oil and into natural gas, we're actually going to save a lot of people from dying, and we're going to save a lot of greenhouse gas emissions. Still, this being a fossil fuel. Of course, if we want to be even cooler, we have the hydropower, solar, wind, and nuclear energy. This is where we want to be in the end. but already moving from coal and oil to natural gas is in itself somewhat of a mitigation. But we have a bigger mitigation going from this down to here. So how does it look then? We've already looked a little bit at this, but this is how much of all the energy used in society. So this is for heat, electricity, and transport, everything. We see the different sources of energy production. So we see that traditional biofuels, we talked about this before, it's using wood and etc. As your energy source, burning wood. Coal, oil, and natural gas. So coal and oil are the biggest ones, and they are the worst. Gas is third. And we see also the other sources, so the low carbon sources here: nuclear, hydropower, wind, solar, etc., etc. We can also look at this perhaps in this way, so we can more easily see the shares. So we see that so this looks at how much of any given energy use at that time is provided by any given source. So we see that this would be traditional biomass dominated fuel use up until the Industrial Revolution, where coal and then oil started becoming more important, and natural gas in the end. So basically, we're kind of seeing that coal and oil are being, well, mostly we've had traditional biofuels being pushed away, but we're starting to see that renewables are starting to become more and more important. So that's quite neat. However, we do still have quite a lot of gas, oil, and coal, so fossil fuel driven energy production. And if you just look at electricity in the top, we actually have about, in the world, somewhere around 36% of all electricity is produced by the low carbon intensive parts. But as you see, that's only about half or less than half of all energy production. So there's a lot of talk about the way we're gonna solve this is basically making all of this energy use come from electricity in some point. So basically, you can use electricity for heating, but that would of course then increase the amount of electricity we have to generate through renewable energy sources. So they're not there yet. But hopefully they will be, because the electricity production through these different sources is changing quite a bit, actually. Well, it's not going super fast yet, but it is changing. So if we look at the share of different energy sources to electricity, we see that there's a quite noticeable increase in the renewable sources in the share of electricity production. So this is what we need to beef up quite heavily over the next decade. And we also noticed that the amount of electricity produced by fossil fuels or renewables or low carbon intensive sources varies quite dramatically over the world. So we see many countries rely quite heavily on fossil fuels, like South Africa, Australia, India, etc. Whereas other countries like Brazil, France, and Sweden use quite or very little fossil fuels for our electricity production. So it varies quite a bit all over the world how much we use renewables for electricity. Even though we see that, of course, South Africa and Australia both have probably quite high availability of both sun and wind, so they should be able to get here at the end as well. But at the same time, we also see that the per capita electricity consumption is both in level, then also varies quite a lot throughout the world. So for example, in Sweden we use per capita about 16,500 kilowatt hours of electricity per year, whereas the world average is less than 3,000. So your average Swede is about then 5 times higher electricity consumption than the world average. It's pretty interesting. So the take home are so we said only the percentages before here. Let's see, this is basically what we've said before as well, looking at how these trends are looking at throughout the world. So coal is decreasing. It's becoming more and more expensive for companies to use coal, and wind and solar are becoming very, very cheap. So they're on the rise. Which we can see here as well, that renewables are increasing quite a lot in their share of total energy production, and this is if you look at the absolute sources instead of values instead of percent. But basically, so far then, our energy production is not up to it's not able to be decarbonized, being that they are produced by hydropower, nuclear, wind, solar, and so on. So at the moment, the best way we can perhaps, or some argue that the best way we can mitigate at the moment is reducing how much energy we use, since we can't say that our energy sources are decarbonized yet. It varies, as we said, throughout the world. Quite a bit, but one effective way would be use less energy until we've come to the point where energy production is more strongly decarbonized. Okay, so how can that happen? Well, there's one way is to consume less, basically, or do it in more clever ways. So we can reduce our greenhouse gas emissions by basically by consuming less. There's less production, of course. So if I buy clothes, of course these clothes have to be manufactured in factories that require energy. They need to be transported from that factory, and you need to use energy to grow the crops that produce these the fibers. If I instead opt not to buy, or instead buy secondhand products, basically we for every cycle of new individual buying the same clothes, you of course reduce the impact of that production. And in Sweden, for example, the average per capita carbon emissions are doubled if we take into account the emissions caused in other countries by our consumption. So here, for example, we can see the greenhouse gas emissions that this is what we call looking at territorial greenhouse gas emissions. So basically only greenhouse gas emissions that are caused within your country contributes to people's carbon emissions or carbon footprint. So basically, if we take so basically all greenhouse gas emissions within Sweden, we divide it by the number of people in Sweden, we would say that every Swede contributes then about 4 tons of carbon emission or carbon dioxide equivalent per year. However, if we then instead assume that the greenhouse gas emissions in, for example, in China, that is used to create products that are exported to Sweden. So basically, the Swedes are responsible for the greenhouse gas emissions of the products that we import from China. Then we see that the average Swede's carbon footprint is instead between 6 or 7 tons per year. So that's about 1.5 to 2 times higher than if we just look at the territorial. So basically, Sweden currently is importing greenhouse gas emissions. more or less. So this is counts using trade deficits and so on. But not only from consumption, we can also look at our own personal transport. So different modes of transport. If you look here on the right, this is from one study looking at the greenhouse or the carbon dioxide production per passenger in kilometers to make it as comparable as possible. Looking at different types of transport. So here we see that flying, assuming the average of 88 people per plane, means that every kilometer of flight produces 2.3 kilos of carbon dioxide. If we look at a car, the average is that 1.5 people sit in a car whenever it's driven. It produces about one, or a small car that is 0.1 kilos of carbon dioxide per kilometer traveled and per passenger. Whereas walking is much less, trams and buses much less. Trams are actually, or trains and trams are the best. Of course, it matters how many people you put in there. So if you put more people in your car, then of course this number is going to change. And we can also look at different fuel sources. So, for example, diesel will generally have lower carbon dioxide emissions, but more harmful particles that kill people. You can also drive your car on biofuels, and assuming a long time scale, that may have no net emissions. However, that's maybe quite a lot of contended. Passengers with A. That's weird, Peter. It's an E here, of course. Then people will say, well, what about the type of the life cycle thing as well? I mean, we have to look at when you produce this thing. Yes, and we can do that too. And here we see that if we take into fact that the fuel is transported to the pumps, and so that would be your indirect fuel cost, and you need to manufacture the car. We see that large cars, like your SUVs and your long flights, those are actually quite comparable, being about 0.3 kilos of carbon dioxide per passenger kilometer traveled. Whereas smaller cars have less. Electric cars, a lot of people talk about, well, it takes way more to produce emissions to produce an electric car. Yes, if you take a small car and an electric car, sure, it's a bit different. However, a large car and an electric car, usually you see that they are quite different. And the indirect fuel cost, if you assume the US grid, which is about 60-70% is fossil fuel, here the fuel still produces carbon dioxide because you have to create that electricity by fossil fuels. However, if you take an electric car on the solar, then you would have less than 0.04 kilos of carbon dioxide per kilometer traveled and passenger. So basically, electric cars are good if they are on a decarbonized grid, like they would be in Sweden, for example. Look, Eurostar. That's where everyone should move to France and travel by the Eurostar rail, apparently. So this takes into account this might be the most interesting kind of comparison. Still, again, only one study or several study, or the outcome of several studies put into one. So other sources might differ slightly. But anyways, personal transport matters. Walk or bike if you can. If not, try to use these kinds of things. Food production, we talked about as well, accounted for about 25% of all emissions. So there are emissions from food production in many ways. We have to use, so there are indirect ways, for example, through, 3 kinds of machines that need to work the soil and food processing, food packaging, and food transport. But you also have, of course, emissions from the soil itself, and you have and from the if you take animals into account, you have your beef herd, for example. So the cows, they produce greenhouse gas greenhouse gas emissions through their gastrointestinal systems. So if you look here, if you just look at production, we'll see that this is the same line that would go through the same level here. We have to make this one, basically the scale here is much longer, so it wouldn't fit. So they reduce this one. But basically, we see that animal products generally tend to have much higher greenhouse gas emissions than vegetarian foods do. But you also have to take, and into that you also take the land use that you have to use. So how much of the agricultural land do you need to produce animal food compared to vegetables? And you need way more here. That's because of the second law of thermodynamics. So basically, go vegetarian, go vegan. And if you have other things as well, but we're going to get there with chapter 5 later. So here, this is from a study from an American scientist now living in Sweden. And they looked at the amount of savings a person in a rich country like ours can do by different lifestyle choices. And here we go. We start over here. These are the height here is how much savings you do every year in tons of carbon dioxide equivalents. So upgrading your light bulbs, that doesn't impact quite a lot. There is an impact, but it's low. Hang your clothes instead of using a dryer, quite low. Recycle. So instead of things ending up on a landfill where it produces instead methane, you save some there. Washing in colder water saves a little bit. Replacing your car with a hybrid, that saves a little bit, but half a ton. Eating a plant-based diet saves quite a bit. That's more than 0.8 tons per year. Switch your electric car to car-free. That's this amount of savings. Buying green energy, so renewable energy, saves quite a bit. Avoiding transatlantic flights saves quite a lot. Living completely car-free. That's going from this one here, I assume. Saves quite a lot. Having less children saves the most. So the idea here is that you have cumulative emissions from the descendants that decrease by every step. So your children's emissions are you get half of those basically, and their children's you get 25% because you're now just one of 4 people that contribute to this person, etc., etc. So assuming that they emit the same way as people do now. But these are the things you can do yourself. So live car-free, avoid flying, and eat plant-based. That's basically the most impactful things you can do. Also, of course, this is perhaps one of the major things you can do is be active politically. Because most of the things that have to happen are above your pay grade. So basically we have to do all of these things. There's no way we can reach the 1.5 goal without having lifestyle choices, but you can't reduce it as well by just lifestyle choices. You have to also change the system itself. So both things have to happen. And so being politically active and voting for parties that put climate change high on the agenda, it can be very important. So what can we do then on a slightly higher scale than on an individual? So basically as companies and governmental level is looking at energy choices, of course. And there are ways we can actually work with our energy sources, apart from just switching off from fossil fuels to, of course, to the renewable ones. That's perhaps the best one. This is a kind of a high-tech solution that is so far quite unproven, what we call carbon capture and storage. So basically then, if we compare the fossil fuel and the fossil fuel with carbon capture and storage, these arrows kind of, or lack of an arrow, shows greenhouse gas emissions from different energy sources. So with fossil fuels, from the land up to the atmosphere, carbon dioxide just goes straight up. With wind and so on, we have basically no greenhouse gas emissions, so it's just a dash. Bioenergy, the biofuels absorb carbon, and then we emit carbon by when we burn them, but they can be balanced, so it can be net zero. With a fossil fuel with carbon capture and storage, basically we capture some of the carbon emissions going out and pump them back underneath the ground, so our emissions are reduced. However, if you put carbon capture and storage with bioenergy, you can also actually take down, you can imagine that the biofuels take up the carbon, and then when we burn them, we only allow, we capture a lot of the carbon and put that underground. So basically then you would have more carbon going from the atmosphere to below ground than you have going up. So basically we have a net negative emissions here. So negative emissions is sometimes what we call this. Whereas here it's just reduced net positive. Okay, so let's look at it a bit on this. So these are different emissions scenarios to reach the 1.5 goal. So how are we going to get there? So this is scenario 1. And these are emissions from different sources. And this is from forestry, the brown one. And this yellow is this bioenergy with carbon capture and storage. So these are 4 different ways we can do it. So if we start reducing our emissions early and quite rapidly, we won't have to rely on these kind of things that we don't have even a prototype. There's no prototype plant of this yet. This is just something that people imagine that could work but have not done yet. So basically, if we do that and we allow basically our forests to regrow, we can reach this quickly, or kind of quickly reduce our levels, and we can basically reach that goal. If we start later, the later we start, the more we require to use these or similar technologies like bioenergy with carbon capture and storage. So the later we start, the more emissions we produce before we get to this point. So the more we have to invest in these kinds of negative emission technology. And the problem, of course, is that we don't know if we're able to produce these negative emission factories, or what do you call them? Plants. So that's a huge risk, and we also don't know how will the climate system respond during the time that these emissions kind of go out. So let's look at a little bit more at this carbon capture and storage. So here we have some examples of where you could store these carbon. So basically, you have to have these point emission sources like your coal burning plant or natural gas burning plant or something like that. So we put the carbon dioxide into coal beds where they would be, or that it's actually already used in that kind of sense, where we push them into oil beds where it makes the oil easier to extract. But you can also put them into old oil or gas reserves, together with chemicals that kind of make the gas binds the gas into solid. We can also pump them into the ocean water at the deep levels where they wouldn't necessarily come back to the atmosphere. So basically, as I said, this reduces the emissions. It doesn't provide us with net negative emissions. and increases the cost of the energy, because of course then the producers will have to pay for this, and then where will they get the money? They will get it from the consumer. So as I said, it's already being done. We push carbon dioxide into oil wells, and that makes the oil slippery. It otherwise sticks to the walls of the oil well, so it's easier to take them out. However, I don't know if they leave the carbon dioxide in these oil wells, or if they're made to basically store this down in these wells. And there are very few, there's basically only a few plants that have these kinds of things installed. And in Norway, they're actually working on a prototype plant to with pipelines to push the carbon dioxide, compressed liquefied carbon dioxide into the ocean. However, the market for how this would work, basically, if Sweden wants to use that one, they want us to basically pay for the production of this this plant before it's being produced. So it's a little bit tricky. So using biofuels instead, of course, we can then make biofuels into this fast carbon cycle. So you would have equal amounts going up into the atmosphere as being absorbed by the plants. So basically, you have a quick cycle instead of the comparable fossil fuel cycle, where fossil fuels are storing carbon dioxide for very, very many years. So basically, any use of these will add net carbon to the atmosphere. However, still oh my god, I'm trying to go backwards. However, still, this is still decades, and we don't have decades at the moment. So that's the big controversy regarding biofuels, that we don't have the time basically to consider a net zero emissions from biofuels. And again, this is how the bioenergy and carbon capture storage would work. You'd have fast growing plants that you would have to then burn in a power plant or heating plant, and you would capture the carbon from them and put them in geological storage. Of course, the problem is that we have to then use land that otherwise would be used for agriculture or for biodiversity, and use them as a fuel source. So basically, we have to compete with food production and wildlife to do this. And as I said, it is not developed yet. So we would have to have an enormous scale of these kinds of plants to be able to the power plant, or to reach the kind of levels that people hope for. So basically, this is a risky business. You can also watch this little video about another way of doing it. So I'm going to assume you do that, because I can't play it in this one without being blocked. So watch this from the PowerPoint, and then we can look together. So now I assume you've watched it. So I will go forward. Otherwise, pause me and watch this video and then come back to this. So we're going forward. This is what we call a direct air capture technology that they showed in this video, where you have fans basically sucking in the ambient air, and they separate the carbon from the ambient air and produce either carbon dioxide gas that you can use to fertilize your greenhouses to make your plants grow faster, but the carbon then goes back into the atmosphere. You can also produce biofuels this way, like methanol, or you can, as in the video, you can store them underground. This is very, very costly, but it's a way to get negative emissions as well. You would have to produce enormous amounts of these plants, and you have to pay lots of money to have any impact really on the carbon dioxide levels in the atmosphere. But it's a potential solution, or potential part of the solution. Another way is something we call biochar. That's taking biofuels, putting them in a sealed compartment where there is no oxygen, and turn up the temperature. That requires energy, but if you take renewables to fuel this, you basically produce this biochar that you can put in soil, and then this carbon that's in this biochar is locked away in the soil. So this is one, and it increases the fertility of the soil. So this could be actually very important for agriculture, and at the same time reduce carbon dioxide levels in the atmosphere. So this might be someone's eye, who knows, looking at how biochar works. And let's see. Like I said, another way of doing this is protecting and enhancing carbon sinks. So that would be promoting reforestation and reducing deforestation. So basically increasing our forest cover or keeping it at least. And you can also enhance the carbon dioxide absorption in oceans by fertilizing them to produce algae productivity by iron and so on, for example. And apparently people have argued that whales, or the reduction in whales in our oceans, have reduced our ability to reduce carbon in the atmosphere, because whales bring up nutrients from the bottom of the ocean and they poop in the top ocean, and that poop has nutrients that the algae use to absorb, do photosynthesis and absorb carbon into the ocean, and then they die and sink to the floor, ocean floor. So one way of combating or mitigating climate change is restoring the whale numbers. But we have some impacts of this as well, which could be eutrophication and reduced oxygen levels at the bottom of the floor of the ocean, because the algae that are produced in the fall, when they die and fall to the bottom floor of the ocean, bacteria will decompose them using oxygen, and you will have low oxygen environments at the bottom of the ocean. But planting trees is then one possible way of doing it, and there are non-governmental organizations like this one that promotes forest plantations. And there are actually studies suggesting that we can plant about, a bit less than 1 trillion trees, which would save about 5 years worth of our emissions. So that there's space for that, basically, without removing houses or encroaching our agricultural land in the best case scenario. And here's a small video about that. But so basically we talked about a few different ways of removing carbon dioxide from the atmosphere. That would be bioenergy and carbon capture and storage, forestation, direct air capture, biochar. You can also fertilize the oceans, and the one thing we didn't talk about is adding certain minerals on soil so they would absorb carbon dioxide. I think we're gonna stop there, actually, because it's getting a bit long anyway. So we'll continue with this a little bit later, basically perhaps on Friday if I'm back then. So enjoy this. Hope you enjoyed this video, and if you have any questions about it, you can reach out to me. Bye bye.